So, the sun. The problem now is how you integrate this magnetized ball. And by the way, sunspot come and go. Clearly that you can control the amount of light output, right? Because the amount is very tiny, by the way. It's of the order of 1% when the size of the dark area is small, even up to few percent actually, very large in instant. And then it's actually very small, of the order of 0.1% coverage. So it dimmed the light by that much, basically. But the problem of studying the sun is not studying the sunspot alone. Most of the problem is that since we are able to put the satellite up to do the measurement, mainly that we've been trying to understand how much the sunlight outputs have been changing, started by the Smithsonian Institution, by a guy named George Abbott in the early 1900s, who tried to do this this program by the gift of James Smithson, this clockmaker, who tried to make us understanding the fundamental study where I am now at, Smithsonian Astrophysical Observatory. It's very sad that they tell me not to study the sun climate, which is really bothers me. But that's another side of the story. But it started by Abbott, and then Langley first, Samuel Langley, and then Abbott, and then another director of the Smithsonian, who've been actually trying to measure this light output. But they've always been able to put only a telescope on top of the mountain tops. And that's not good enough, because the amount changes is so small that any changes in the transparency, which means between Earth and the sun, like cloud, then all games are off. Essentially very hard to recover the information. So only when we go above the atmosphere, started with balloon stuff in the 50s and 60s, there were some measurements and really good effort trying to measure what the sunlight. Then we have satellites. Ever since then, we were able to confirm the facts that when the sun is more active, which means there are a lot of sunspot. So you can imagine what happened. A lot of sunspot. Shouldn't the light be dimmer? No. The sun get brighter. That was the first surprise of the satellite results. And there was no explanation immediately because people was just surprised. It turns out that it's not because of the sunspot that is really governing the effect of this light output. It's actually the smaller magnetic skew element called the facules, and there's another name called plages. Those are bright region on the sun that magnetize also. They are less concentrated in magnetic field, so they are order of 100 Gauss and even a few Gauss. But they are smaller region compared to sunspot. Sunspot, by the way, one sunspot can be, you can fit 3-4 Earths inside it, even Jupiter is big, okay, the region. So those big region are overcompensated by the light emission. So the sun gets more active. When you say the magnetic field of the sun is stronger, it gets stronger. So that was the first explanation, but the rough explanation is because of that, right? And then again, the usual IPCC school is to say that we have known everything. Willie Soon is always wrong. He's so stupid. He cannot do this, cannot do that, cannot study this, cannot start that, cannot ask question. I immediately asked the question, what would happen? So by the way, the satellite, we can observe only about 3 so-called sunspot cycles. If you say that you studied 3 sunspot cycles for over 30 years, that's good enough to understand the sun, how it varies over 1,000 years or even hundreds years, Good luck. I don't think so. So we immediately asked the question, would the sun do anything different in the time like we know as Maunder minimum, when the sunspot, Maunder minimum is a period from 1645 to 1715. The most famous person during that time was so-called the Sun King, Louis XIV. Apparently, the rumor is that the Sun King appears with the sunspot hideaway. They are scared of the Sun King. He was so powerful. That's only a legend, mind you. But that time, apparently we have enough information because, you know why? Thank God to Galileo Galilei and a bunch of those early pioneers. They started to realize that you can use telescope to monitor the sun. So they were actually using the telescope to watch sunspot, count sunspot, project it carefully and study that, including this Jesuit priest by the name of Christoph Scheiner. And then in England, you had a bunch of those good people also was measuring. So a few people around. And I found out that also the Asian, in China, Emperor of China was also very fond of studying the heavenly bodies. So there's a lot of information there, which is yet to be fully explored. So that's part of the work that I'm working with some Chinese colleagues. And thank God for them initiating the project. So the French were excited, all these scientists at Observatoire de Paris, who was formed at that time where people were trying to concentrate on zero longitude, how to find the clock. And they started this observatory to make what you call precision astronomy. That you try to define this, so they started observing the sun. To their great disappointment, they monitor the sun, but the sun doesn't seem to put out so many sunspots. So they actually initially thought that Galileo was lying. Better go check him. Better go check all this old record. What is going on? How can it be? Right? So it turns out that from that period, 1645, they observed, quite early on, 1630s, they got information. In fact, there's another husband and wife team from Poland. They were also observing them. And they found a lot of sunspots actually during early times. The Danish guy, one Danish observer was also observing that. So in fact, his name is Hevelius. Hevelius is actually the guy who is what you call the Polish astronomer, but he was living in Denmark somewhere. And they were observing this, and then they realized that the Paris Observatoire de Paris scientists are very careful. They map the relative location of the spot on the surface of the sun. They immediately realized that the sun is actually tilted on the orbital plane by 7 degrees. You can see all this map from Galileo's picture when I show in my talk. You will see this thing. And they show the map that sunspot didn't appear in the northern hemisphere of the sun. And then some sunspot does appear. It's not completely disappearing actually. Very small amount of sunspot appear, but they are not appearing in the usual location like 40 degrees, starting in 40, 50 degrees, migrating down and have the butterfly wing. If you look at the plot of this butterfly wing, it's actually a broken butterfly wing in the sense that the left one is disappearing and then the right one appearing, but very narrow. It's like this. So my good colleagues, Professor Elizabeth Nam-Reeves, she was the one that actually encouraged me to study this about the sun. She's from Observatoire de Paris. She died very young, but a really good solar physicist, and went into the study of this. By the way, she estimated that the Maunder minimum to the present time, the sun irradiance could have changed on the order of 0.5% to 1%. Yeah, she estimated very early on. Guess what we found? Independently from our study of sun-like star, we can say anything from 0.2 to 0.7. The best probable mean is 0.4. I've done that with the graduate student from Harvard University, and we produced that work in 1994. Will never be able to be disproven. These people say these jobs are all done, and it's just not true. That's the problem. So that was the goal, to try to understand how much the irradiance of the sun can change or not change, right? We need to understand it could, by all means, it could not change actually. But the point is that the fact that it's not changed is not viable because we have detected that it's changed. Not only that, the real interest about Maunder minimum is that it so happened to form in one of the coldest periods on planet Earth. It's called Little Ice Age. Little Ice Age, in terms of the time extent, cover much longer time than Maunder minimum. It was anywhere from 1300 to about 1900. So the coldest time on a lot of areas in Northern Hemisphere especially is around 1700. Like for example, our friend Willie Soon just showed a Scottish temperature record for the last 800 years, showing that the coldest period is about 1700 in Scotland, using one of the proxy. And the point is that why you call it Little Ice Age. It's not all about measurement of temperature. It's not that at all. It's actually the size of the glaciers all over the world grown to a maximum size actually. You can see the glaciers in New Zealand, the mountain tops in Argentina and forest area. You saw all of those evident all over the world. In fact, that was one of the things that got me into big trouble. By writing a paper that shows that this globalness of the Little Ice Age and the medieval warm period does exist, is real. It's been measured in so many of these archives, plus historical documentary, so many things. Angkor Wat, you can imagine medieval warm period. Angkor Wat was building there about 1,000 years ago, in civilization there. In forests in Argentina, you can see it extended another 100 or 200 kilometers south from what current position is. So many evidence that is so clear that this thing is real. And then the problem there was a guy named Michael Mann from University of Virginia in the beginning was making the claim that no, little ice age, the temperature on the northern hemisphere didn't change at all. If it changed, it's only 0.1 degrees Celsius. That's 1 degree Celsius, too hot. It's too much. 0.1 is very, very difficult to measure, by the way. And these people claim that they can use this indirect 3-ring proxy to measure 0.1 degrees Celsius. You got to convince yourself whether that is true or not. But we published a paper to be honestly discussing the issue. And that's why the one that got me into quote-unquote political trouble, that I'm taking side and so on and so forth, has nothing to do with that. It's just simply trying to understand what is going on. Is what Michael Mann say is true or not true? That's about all you are interested in, right? And that's when the study of the sun becoming a very problematic. I mean, for the social psychological reason and history of science reason that I have to mention this. Part of the reason why I published a paper in 2003 against Michael Mann's famous hockey stick paper is simply because that from the time period where his last paper in 1999 to about 2002 or so, that if you want to study natural climate change, natural really mean that it's not man-made, okay? That you want to study whether it can vary naturally and how large and how small. By the way, it's not interesting to just say that it can vary very naturally. If it doesn't change like 0.1 degree,